shield, and I'm drawing a blank on the other one. What was the last volcano we talked about? Cinder? Wasn't the other one Cinder?
Yeah.
So there are the three types of volcanoes, and then the way that they explode. So what actually causes a volcano to erupt? The dissolved gases, mainly water vapor and carbon dioxide, will build up over time. So there's this pressure that's going to build up. The closer the gases get to the surface, the less pressure to kind of hold it down. So I mean, that makes sense. The closer it's going to get to the surface, the less pressure there is to hold it below the surface. So there's less stuff to keep it underneath. So the less pressure allows the gas to suddenly be released, and that's what causes the volcano to erupt. It's going to spew many things into the air: pieces of rock, pieces of gas, pieces of ash. It's going to have the lava, of course, because remember, it is lava when it reaches the surface and magma when it is underneath. It can be very fluid, it can be very thick. It depends on what kind of material it is and how much moisture is present. The more moisture, the more fluid it's going to be. If there are some openings already, then the gases can be released more slowly, and there isn't going to be like a big explosion. Then the gases imagine like a balloon that has a slow hole, then the air can escape very slowly versus popping a balloon. Like a pop would be like a volcano explosion versus a hole that's allowing the gas to go out very slowly.
They burn. Bottomless cauldrons fueled by each rack, bubbling and boiling thousands of miles beneath the surface, and just waiting to burst through. Volcanoes are scattered across the planet. About 1,500 active volcanoes can be found across the world, though countless others are on the ocean floor. Most volcanoes, whether on land or underwater, are located where tectonic plates meet. In fact, the Ring of Fire, a path that traces the boundaries between several tectonic plates around the Pacific Ocean, contains about 75% of the planet's volcanoes. There are several types of volcanoes, primarily classified by shape and size. Major types include stratovolcanoes, which often appear as tall as steep mountains; shield volcanoes, which are flattered and dome-shaped; calderas, which are large depressions in the ground; and mid-ocean ridges, which are underwater chains of volcanic mountains. No matter their shape or size, all volcanoes emit gas and molten rock. The journey of these emissions begins deep underground in the Earth's core. The core, which can burn as hot as the surface of the sun, transfers its heat to the surrounding rocky mantle. In doing so, the heat melts some of the rock. This molten rock, or magma, is lighter than the surrounding solid rock layer, so it rises through the mantle. The magma then escapes through vents in the Earth's crust, causing volcanic eruptions. Now above ground, this magma is referred to as lava, and it can reach temperatures of over 2,000 degrees Fahrenheit. In addition to lava, volcanoes may erupt with searing hot gas formed in the mantle. In a phenomenon called pyroclastic flow, this gas, combined with hot ash, can race down the sides of a volcano as fast as 100 miles per hour, burning everything in its path. To measure and classify eruptions, scientists developed the Volcanic Explosivity Index, or VEI. It considers various factors, such as the volume of lava, gas, and other emissions from the volcano, along with the height of the eruption cloud above the volcano's summit. The VEI scale begins at 0. Each successive measurement increases logarithmically, meaning that each magnitude is 10 times more powerful than the one before it. The VEI scale does not have an upper limit, but the most catastrophic eruptions measured thus far are categorized as VEI 8. These eruptions occurred thousands and millions of years ago. The most destructive volcanic eruption ever witnessed occurred in Indonesia in 1815. Mount Tambora, a large stratovolcano, erupted with a VEI measurement of 7. The blast caused earthquakes, tsunamis, and pyroclastic flows that decimated the land and took tens of thousands of Indonesian lives. The eruption even destroyed the top of Mount Tambora itself, turning the 13,000-foot tall mountain into a 3,640-foot deep caldera. While volcanoes are some of the most destructive forces of nature, they have also helped make life on Earth possible. Volcanic ash provides nutrients to nearby soil, making the land fertile. And lava, when it cools, hardens into rock and creates new landforms. With heat from the heart of the Earth, volcanoes have helped terraform the planet, making it the rich, dynamic landscape we see today.
It's also kind of fun just to watch some of those volcanoes actually explode and see the actual lava. But depending on the type of eruption, volcanoes may produce lava flows or eject what's called pyroclastic material, or both. And all volcanic eruptions emit large amounts of gas. So the gas is one of the things that causes the eruption, that buildup. We can have the ash go up, or sometimes the magma will come out the side and turn into lava. Sometimes it just kind of slowly goes down the side, and sometimes it's so explosive that it tears up the whole mountainside. Sometimes it's so explosive it can tear up the whole mountainside and, like it was saying in that video, create like a whole kind of concave part that tears up the whole mountain. You don't see it either in the pictures. The key is wrong. So there are different types of lava flows, depending on how the lava cools, how fast it flows. One of them is called pahoehoe, which is it's hotter, faster moving, and basaltic lava. There's a type called II, which is cooler, slower moving basaltic lava. And then there's also one that's called blocky or pillow lava. So this one is cooling kind of fast and kind of like a pillowy effect. So it looks very, I don't want to say fluffy, but it looks kind of roundish because of the way that it's cooling. So lava cools in different ways depending on how watery it is, how much exposure it has to the surface, how the viscosity is, what kind of minerals and rocks are in the lava, and all of that causes it to cool at different temperatures, and so of course scientists have named it. I don't know if these are like Hawaiian names. They sound kind of Hawaiian names.
What was the second one pronounced?
II? But I'm pretty sure this one's Pahoihoi. Pahoihoi. Well, we already know pronunciation. Not my area. So this is in Google Classroom, and it explains the different kinds of lava flows. The lava pours out quickly and forms kind of like this brittle, kind of crackly crust. And then the lava typically flows underneath with the crust on top still kind of a solid. The Pahoihoi lava flows very slowly, kind of like wax dripping is a good way to think of it. Glassy surface is kind of round and wrinkly. Pillow lava, this one often is under the water. You can see this, that it's rounded and kind of lumpy. And then this blocky lava, it's cool and stiff lava. It doesn't really travel very far from the eruption, and it's usually oozes from a volcano and forms kind of like these jumbly heaps of sharp area. But this does a really good job of showing pictures and having descriptions. So this picture is in Google Classroom for you.
That can be part of the test.
It will probably have a question about this on the test. Yeah. All right, so aside from the lava, the gas and ash produced can also have a high impact on the environment because it's going to spread. That's why this has such a big impact. If you can imagine all this ash in the environment, it's going to spread out over a large area, and that's going to influence the amount of sunlight. It's going to coat the plants. It's going to produce acid rain. So it's going to put a lot of carbon dioxide in the air. It's going to do a lot of different things. So it's not very good for the surrounding area, and it can have an impact on a huge surrounding part. So it can travel quite a distance and release water vapor, carbon dioxide, nitrogen, sulfur. A lot of different things get released when a volcano erupts. Not just lava. And the lava, it's not good. It can start fires and it will damage the immediate area. But this has a more wide range impact. just the lava. So fragments of the mountain that it has exploded from, pieces of debris, maybe even like little pieces of rock, and even trees if there were trees or other things that were on that mountainside. So that's pyroclastic material. It could be very fine dust particles, or it could weigh several tons if the mountain like blew out a side. Then it could shoot like a whole side of the mountain off. That could be considered pyroclastic material too. So this is the physical stuff that gets spit out during an eruption. It could be tiny, it could be big. It's the stuff that gets spit out besides just the ash when the volcano erupts. Go. It's gone. Come back. That's alright. That was our last slide anyway. So that was our oh wait, we came back in time. We watched the video. Yay! Maybe, thinking about it. Come on, computer. You can do it. Oh, there we go.
What should you know about the potential impacts from ash fall? Jen Moniza found out. Jen?
So according to the USGS, ashfall can impact us in numerous ways. More ash equals more potential hazards. So the amount of ash released into the air from Halemaumau will determine how serious the matter is.
The ash plumes on the Big Island have many concerns. The big question is, what will happen if you inhale the ash?
Ash is particulate matter that blows out of the vent, can cause irritation and basically an acid burn of the lung, which causes a lot of coughing and wheezing and respiratory distress.
What can people do to prevent and protect themselves from the ashfall?
The most effective thing is to move out of the area where the ash is falling.
But what if you can't do that?
One of the easiest ways to reduce the health risks associated with ashfall is to use one of these. It's a particulate mask and it goes on pretty easily. You can get
We're a little
these at
familiar with
any
those by now.
neighborhood drugstore.
Brady also suggests staying indoors in an air-conditioned room, avoiding outdoor exercise, using an inhaler if you're having bronchial spasms, wheezing, or excessive coughing. He also says seek medical attention if symptoms persist. The ashfall could potentially impact other things, like electricity.
A light dusting of ash in combination with moisture on our insulators could cause electrical short circuit, and that could result in power interruption.
Hawaii Electric says it is ready to respond if this happens, but it could be worse, depending on how much ash there is.
This is a widespread situation. Power restoration may take longer.
They tell me they are monitoring the situation closely and advise the public to follow civil defense alerts.
This
If
video is
ash gets
obviously
into your
pretty
water-
old, but the information is interesting. I think it was funny that they mentioned the mask. Like, we didn't know how to put masks on. That's a little old news by this point. Anyways, so that's all the information that we are doing for today. I am getting ready to post your assignment, and the assignment that we are doing is we are actually going to make volcanoes, but the explosion that we are focusing on is we are actually going to do an explosion with Mentos and sodas tomorrow. And so for us, we are